So today we start a new chapter. And if you notice, another super small chapter. You feel it doesn't seem to feel very thick, right? I said earlier, the first two chapters of the year were super big. After that, all the other chapters are sort of like this. Now, unfortunately, we are like, what, a week and a half away from spring break. So this tiny chapter is going to get broken up over spring break. So we're not going to be able to get it done before spring break. So we'll get it started here, and probably within a week of coming back, maybe a week and a half, we'll probably be wrapping it up and there'll be a test. So it's kind of weird because you have spring break in between, but that's just the way it happens. It's okay. We'll do reviews. All right, start off with your names. All right, we are in block H. All right, so this chapter is called Ratios and Rates. And there's lots of things in math that if you're not doing a degree in health sciences or engineering, you may not use too much in your future. So a lot of math is just about your ability of improving your problem solving skills. But ratios and rates is something that usually shows up in everybody's life, some way or some form. Okay? So let's go to the first page, and we'll discuss what ratios are, and later on we'll discuss what rates are, right? So in math, often, or in life, we want to compare two or more sets of numbers, and we use something called ratios, right? They show up in lots of different places, right? All right, and we'll discuss those throughout this chapter. Now, so we're going to compare different sets of numbers. Oliver, start writing some of these notes down, right? Now, for instance, maybe you have a shop and you sell fruit baskets, and you have a basic fruit basket and that has apples and pears in it. And your formula for selling your fruit basket is comparing apples to pears. And your way it works is, hey, for every 2 apples, I'm going to put in 7 pears. Right? So the little dots there, those things mean ratios. Right? This tells you what the relationship between the two things are. And on the top I wrote down, hey, this number is for apples, this number is for pears, so we sort of know. Right? And suppose that is your basic entry-level fruit basket. And you go, hey, maybe we sell a little bit better one with more stuff in it. And the other one has 4 apples in it. What do you think how many pears you would put in it? 14. Because this is how these are connected. For every 2 apples, there's 7 pears. So if there's 4 apples, there's going to be 14. Right? That's it. So comparing 2 numbers, and it starts off like this. We will get into slightly more complicated, but that's the general idea. Now, lots of times when we're comparing things, it's only 2 things. But it could be comparing 3 things, right? Or 4 things. There's no limitation of how many things you're comparing. Suppose in the same one you have a Supreme basket, and then in that one you have bananas in it. So you have apples, pears, and bananas. And you say, hey, we have for every 2 apples, yes, we have 7 pears, but we can throw in 1 extra banana, right? So this is a Supreme basket. Right? So, if we want the supreme version of your basket to have 4 apples in it, how many pears would be in it? 14. How many bananas would there be? 2. Right? Basically, to go from here to here, we multiplied by 2, and everything doubled. Right? So this is just a relationship telling you, hey, this is how these 2 numbers are connected. Right? And we do a lot of stuff with that. Okay. So now let's do some more practice, just writing things down. Now, suppose in this question we want to write a ratio of 3 oranges to 5 apples. what order do we write these numbers down? Do we go 3:5 or do we go 5:3? Which order do we write these numbers down? One is right, the other one is not.
3 to 5.
You're correct. Why did you say 3 to 5?
Because for the other one, we wrote lowest number to highest number.
So it is not necessarily lowest number to highest number. We sort of did it on this one here, but we didn't do it this one there. So you guessed at the right answer, but there is a different reason, right? It's basically this order that they show up in the information. So we talked about oranges first and apples second. So that's how we talked about it. So our relationship is oranges to apples. So we're going to say 3 to 5, not 5 to 3. Just the order it showed up in the sentence. Right? Not hard. Okay? So let's do some more practicing. Now, technically, we don't need to write these letters down for ratios. But to help avoid flipping the numbers around, right, I encourage all you guys to write these letters down. It makes it a little bit easier. Okay? So now our next ratio we want to write down is comparing students wearing hoodies to non-hoodies. Right? So we're going to write down maybe H for hoodies and N for maybe no hoodies. Right? That's the order the information was asked for. So let's look at this class. So this is for this class. How many of you guys are wearing hoodies? A lot. Count them. Everybody agree with Ava's count?
No.
There's 14.
14?
I know I did count.
No, Kaylee's doesn't count as a sweater.
Kaylee's is a sweater, not a hoodie.
It's not a hoodie.
So 13.
You were
Yeah.
So it's 13.
So it's 13. Okay, so there are 13 students in this room wearing hoodies. How many are not? 3. So there's,
Only 16 of us.
yeah, there's lots of people away today. All right, so this chapter, especially the first part of it, it's just your ability to count, right? Okay, so now, another one. Comparing hats, kids wearing hats versus total students. So we're going to say maybe H for hats, maybe T for total students. So how many people are wearing hats? 2. Versus 16. All right. All right. So the next one is asking us to compare 3 things. Blue chairs compared to gray chairs compared to all other chairs. So in this room, how many desks have blue chairs?
1.
2. There's one empty one there, and we got somebody's sitting on one, right?
Oh yeah, 2.
2. How many are gray? There is no. There is 1. That's Romeo's chair, I think, right? Yeah. That means, well, how many aren't blue or gray? How many desks are there? You guys in rows of 6, 6, 6, 6, and a 5. So there's 29 desks in this room. So how many are left over?
26.
26. Yeah. There we go. That's it. Not too hard. Right? Right? Just counting and new words and how to represent this information. Okay. So now, ratios in this format is just one way of writing numbers. There's other ways of comparing numbers, right? So we have ratios like this. For example, we're going to use this scenario to discuss all the different ways we can compare numbers. Suppose there are 14 hockey players to every 9 soccer players, and we have 23 athletes all together. We can write this as a ratio. So we can say hockey players to soccer players. And how would that look like, our numbers? Right? Our numbers are 4, 9, and 23 in the question, right? So, sorry, 14, 9, and 23. What goes underneath the H? What goes underneath the S? 14 goes here, and under S, 9. This is 9 soccer players. Okay, so now, as a fraction, so this is as a ratio, one way of writing a ratio, right? We can't go, we can't go like this. 14 over 9. We can't write a fraction like this, right? The problem here is the bottom number. So when we do fractions, the bottom number is supposed to be a total, right? The 9 is not a total. So we can't write this fraction like this. So if you want to talk about hockey players, you would say, if you want to talk about hockey players, we go 14 over what number? 23, because we have a total of 23 athletes. So 14 out of the 23 are hockey players. That makes more sense. 14 out of 9, that doesn't make any sense. 14 out of 9 soccer players, that doesn't make any sense at all. We're just talking about hockey players. We could say soccer players and write another fraction for it. We could say there's 9 out of the 23 soccer players. So sometimes there's more than one ratio or fraction we can write down. And you just have to be clear what you're writing down. Okay? Okay. So another thing we can do is we have a fraction, and we can also do a percent. And we just did a whole chapter on percents. Right? So let's just do the hockey scenario. So for hockey, right, we have 14 out of 23 players are hockey players. How do we turn that into percent? Do you guys remember this way? How do we do this? Nash?
Isn't it 14 divided by 23?
Yeah, you turn the number into a decimal, right? So we got the decimal version. So you go 14 divided by 23 is 0.608. Then it keeps on going. So let's just say we wanted to 2 decimal places. This stay a 0, or does it get round up to a 1?
Yeah, so 61.
61. The 8 says round this up to 1. So this is 0.61, and that's not a percentage. That's our decimal, right? So we times that by 100, or you move the decimal 2 spots, right? And you get 61%. Okay? So one way is our ratio notation. Another way is fractions. Another way is percentage. So you guys are good with fractions and percent. You guys just wrote a test on it. So the ratio is a new thing. The other way is just describing in words. So using a sentence where you can say, there are 14 hockey players for every 9 soccer players, right? So there's 4 main ways that we're going to write these relationships down, okay? We're going to use ratios by the most, ratios and fractions the most, but there's other ways, right? Okay, so let's do some more practice of this. Let you guys write that sentence down. All right. Oh, we've got like a half an hour still left in class. After our notes. Okay. Okay, so for the next scenario, we want to write it in 3 different ways. We're going to write it as a ratio, we're going to write it as a fraction, we're going to write it, 4 different ways, as a percent, and in words. Okay, so we're going to do all 4 ways. So here we go. 7 out of 30 kids at this school went to Albert McMahon. That's the information, all right? So what does our ratio notation look like? Nash?
So, like 7 out of the dots 30.
7 dots 30. So we have Albert McMahon versus total. All right. What does our fraction look like? Logan? 7 over 30 like this. All right. Percent. What percent was that? We need a calculator for that, right? We divide the numbers, all right? Then we move the decimal spot 2 spots. So that'll be 0.23. We move the decimal 2 spots over, and we get 23%. All right? And the last one in words, right? For every 7 students, no, sorry, for every 30 students, 7 went to Albert McMahon. All right. Now, so our first lesson is on ratios. And there are 2 different kinds of ratios. There's only one kind of fraction, because fractions are comparing what you're counting to the total. Ratios are more flexible. You can go something called a part to a whole, means the whole means total, right? Comparing your thing to everything. So for example here, that'd be 7 compared to 30. 7 out of a possible 30 went to Albert McMahon. So that's called a whole, right? That's everything. But there's another version. That's called part to part, right? And that one works slightly different because you don't need a total, right? Sometimes it's nice not to know the total, but the other piece of information. If 7 went to Albert McMahon, what would the other part be? The other part would be the remaining kids. How many kids are left over?
23.
23 kids are left over. And these are the other, right? So these 23 kids out of the 30 went to all the other elementary schools in this town, right? So part to part, comparing the thing you're counting to the total. Part to part, sorry, that's part to whole. Part to part, comparing the things you're counting to all the other things, right? So slight difference, right? One's a total, one's comparing parts. Okay. Let's do some more examples and get this. All right, so we'll do most of the back page, and we'll stop, and I'll give you a break. We're going to start off with over here. All right, so I gave you, we're going to start off the right-hand side, 4 different ways to write ratios. One thing that we didn't talk about, which does not get used very often, but sometimes it's nice, is they can be drawn as a picture as well. So we have this scenario. We have 6 circles compared to 4 rectangles. So we can draw that as a picture, right? So we're going to draw 6 circles, and we're going to have the 4 rectangles. So we can go 6 circles. I'll do those in green here. So, oops. 1, 2, 3, 4, 5, 6. compared to 4 rectangles. 1, 2, 3, 4. That is our ratio. All right? Okay. Technically, I don't need the little ratio dots in there, but I'm going to put it in there. All right. So now, we want part to part. Let's do part to total first. Let's skip B. Let's go part to whole. Remember, whole means just total. This just means total. Right? So in this situation, since we have two shapes, there's two different ratios we can write down. Right? We can say, we can compare circles to total, and we can compare rectangles to total. Right? There's two different ratios we can write down. Right? So what would the circle ratio look like? 6 to 10. Right? 6 of these compared to all of these. And the rectangle one would be 4. No, to total. So there would be 10 total. All right? All right. So now, part to part is comparing the individual things. We have circles compared to rectangles, right? So we have circles compared to rectangles, right? I'm just doing the order that they showed up in the sentence, right? And so we have 6 compared to 4 here, all right? So that's the difference between the two different things, right? Comparing the parts, the individual items, or comparing it to the whole group. All right. Now, just like fractions, ratios can be reduced to lowest terms. So he goes, hey, look at part B. We had this ratio, 6 to 4, right? Comparing circles to rectangles. This comparison is bigger than it needs to be. We can reduce these numbers, right? So you go, hey, is there a number that can divide both 6 and 4? 2, right? They're both even numbers. So both of these numbers could be divided by 2. And so that's 3 compared to 2, right? So for every 3 circles, we have 2 rectangles. It means the same thing, but working with smaller numbers makes the comparison a little bit easier to do, right? So for most of your answers, you're going to come up with your ratio like this. And just like our fractions unit, the extra half a mark for you to put into lowest terms. Is there something you can divide and make these numbers a little bit smaller? Okay? So let's see. We'll do this big chart and we'll call it quits. All right, here we go. Ashley has a recipe for fruit punch. It calls for 3 cans of frozen orange juice. Concentrate. 2 cans of raspberry concentrate. 1 can of lime juice concentrate. On the back of the label, it says to add 3 cans of water, right, for every can of concentrate. So now we want to take all of this information here and write it in the table. All right? So, according to our recipe, how many cans of orange concentrate do we need? No. 3. Right? For that orange juice, how much water do we need to add? 9. Because we need to add, for every can, we need to add 3 cans of water. Right? So 3 times 3 gives us 9. So we need to add, all right? Now we go on to raspberry. It says we need 2 cans of raspberry. How much water do we need to add? 6. 2 times 3 gives us 6. All right? Then we have our lime juice. All right? How much water for our lime juice? How much would that be? 3. Because this is 1 times 3 is 3. So all together, for our totals, we have 1 plus 2 plus 3. We have 6 cans of our concentrate. Right? How much water do we have? We have 18. Thank you, Lucas. All together, we have 24 cans of punch. Okay. So now, let's just answer some quick questions about this. We did the hard part. We got all the information out there. Okay. What is the ratio of orange juice to lime juice? And it says do this in 2 different ways. Right? Yes, it does. Shh. Right? So we want to compare orange juice to lime juice. All right, concentrate. So what are the numbers? 3 for the orange juice and 1 for the lime juice. So that's a ratio, right? So remember, there's other ways. We can do it as a fraction. We can do it as a word. We could do this as a percent, right? In this case, I think it's probably just the easiest thing to just write a little sentence, right? You can also do the 4th one. You can draw a picture if you wanted, right? We can just say, for every 1 lime, we add 3 orange cans. Okay. Next one. Lime to orange. No, sorry, lime to raspberry, it says. Orange, raspberry, and, oh, there's 3 of them. And raspberry. So there's 3 things. Lime, orange, raspberry. That's the order that we want to write these things down. So what are those numbers? All right? What would that be? 1. What's the O? 3. And the raspberry, 2. That's it. Okay. What is the ratio of water to juice concentrate? So we want to go water compared to juice.
Why did you guys write J?
I could write down J. I just wanted to write down juice. 18 to 6. We have 18 cans of water for 6 cans of juice. Right? So just, it's not hard. The hardest part is a lot of information here and just picking out the right stuff. Okay. Next part. How much punch does this make?
24.
24 cans. Right?
We can't see.
All right. So finally, what is the ratio of orange? Actually, let's stop right there. I'll use that as a warm-up for next day before we do the assignment and the other stuff.